Well, hello. Today I like to talk about very important um, theorem here. First of all, before saying anything, this is my primary source, and I also used Zoo's Essential Robust Control book for the preparation of this video. And here, let me say this. Let's talk about this theorem. Okay. G of s be given by a simple x that equals ax plus bu, y equals cx plus du type of state space representation, and of course there is a g of s transfer function associated with this state space representation. Then h infinite norm is less than gamma if and only if, notice there is no conservatism, if and only if condition, there exists a matrix which is positive definite such that one of the following three inequalities hold. And we're going to focus on this inequality, meaning let me try to write this: h infinity less than gamma if and only if there exists p such that, okay, alright, this is what we are going to focus right now. And I like to say this is this is going to be hard, so I'm gonna make everything that I can to make it as simple as possible. And let's focus on the sufficiency part. I'm checking my notes, by the way, to make sure. Alright. Just okay. And a little change of plans. First, I'd like to say this inequality and this inequality, and also this inequality and this inequality are equivalent, and proving that they are equivalent is a matter of linear algebraic manipulation, so I'm going to skip that part. So whenever you see this, think of it as, you might see that as well, or this, you may do some manipulations and get these terms, okay? And let's focus on the sufficiency, meaning I'm checking my notes. Sufficiency, there exists p positive such that pa symmetric, pb c transpose, pb transpose minus gamma identity, okay, d transpose cd and minus gamma identity, okay, less than 0. And a quick notation here, quick notation, pa, or rather this x symmetric operation is x plus x transpose. This is it here, pa plus pa transpose, meaning a transpose p, right? And also p is like, I want to say this actually, I want to say this transpose rather A transpose B transpose. Okay. Yes. And P is symmetric, so we can write this as well. Alright, let's take this. Okay, let's try to prove this part. Alright, okay. This is going to be long one. So suppose that there exists a P positive satisfying this inequality, 3 by 3 matrix inequality, from that inequality we will have if we consider that this is correct. Okay, what we are doing is this: we are considering that this is correct, and by doing some simple manipulations we are going to reach this inequality. Alright, so and this is 3 by 3 and by using what was it, Sylvester's criteria, this must be negative definite 1, first condition. This must be negative definite, and then this must be negative definite, right, from Sylvester's. So let's name this, or rather let's do this. Wait a minute. PA plus A transpose P. Alright. PA A transpose P less than 0. Okay. Which comes from 1 by 1 and 3. And what does it signify? It signifies that A is stable, right? Okay, that's great. So we have this right now. A is stable, okay. And also this must be negative definite, and let me write this here. This must be negative definite, okay. And by using Schur lemma we are going to reach, but let me try that, minus, okay, minus the transpose, okay, alright, okay, this must be negative, and let's multiply it with gamma minus gamma square plus, okay, and D transpose D, gamma square identity. Also sigma max less than gamma. We reach also this information. So what I like to do at this point, it's going to take a lot of space, right? Okay, this is another information. Well, let me search this. 5.8. Okay. Since we consider this as true, we are going to use Schur's lemma, and let me try to do that. I'm going to try to turn this 2 by 2 matrix less than inequality into single line inequality. Okay. PA plus ATP plus C transpose C minus, okay, minus PB plus C transpose D, and at this point let me use this notation: gamma square minus D transpose D. Okay. Inverse plus okay, I'd like to explain what did I do. A, B, C, D, right? Less than 0. If and only if A minus B D inverse C, okay, I just did that. That was A here, that was B here, that was D here, okay, here D inverse or R inverse in this case, and this is C. So I just follow the steps and C transpose. Just give me 1 second. Alright, just check this, and I mean I just written C, but like all the cases this is B transpose because this matrix is symmetric. Okay, so let me not write C transpose. Oh, messed it up. B and D inverse and B transpose less than. Okay, let me use this little. Okay, rather this. Okay, now that I explained this, let me delete this. Okay, so let's focus on here. Let's focus on here, and using R equals gamma square minus D transpose D. But before that, let's one step at a time. This is going to take a lot of time, so we should be okay with that. And we know that this is greater than 0 because we just proved in this step. Okay, so R okay, and here we are going to add 0. What do you mean 0? I mean minus j omega p minus j omega conjugate p, and this is going to be minus j omega plus j omega p equals 0, right? This is 0. So let's add this to PA. Okay, PA minus j omega p equals minus p j omega identity minus a, and let's a transpose p. Let's add this here, minus j omega conjugate p equals minus j omega identity minus a Hermitian times p equals a transpose minus j omega conjugate p minus j omega conjugate minus a transpose p minus j omega conjugate identity. I was neglecting identity anyway. Minus a transpose p equals minus j omega identity minus a Hermitian p. Okay, let's move a little further. So I just wanna keep only this term. Okay, let's write this. So we are going to write PA. Instead of PA, we are going to write minus P j omega identity minus A minus j omega identity minus Hermitian A minus A Hermitian, okay, times P plus C transpose C plus PB plus C transpose D R inverse B transpose B plus D transpose C. Okay, we just substitute PA with this term and A transpose with P with this term. Okay, so for any non-zero U input, pre and post multiply the aforementioned formula with. Okay, this is wow, this is, I hope we will be able to handle this. And what I'm going to do now, I'm going to pre-multiply U transpose B transpose J omega identity minus A minus Hermitian, and post multiply, pre-multiply and post multiply J omega identity minus A inverse BU post multiply. Alright, there are 1, 2, 3, 4 terms. There are 4 terms. What do I mean? Mean 1, 2, 3 and 4 terms. Let's focus on C transpose C term. Okay, actually I'm going to use blue from now on, and U transpose B transpose J omega identity minus A minus Hermitian C transpose C J omega identity minus A inverse BU equals C J omega identity minus A inverse BU. Okay, this was the first term. There are 4 terms, and let's try to do, what is that, minus P. Yes, let's focus on this term now. We just did this and now we are going to do this, right? So U transpose B transpose J omega identity minus A minus Hermitian, again as in this case, and minus P times J omega identity minus A and J omega identity minus A inverse BU equals minus U transpose B transpose J omega identity minus A minus Hermitian P B U. This is the second, okay, term, and let's focus on this term now. So we just did this term and now we're going to do this term, and U transpose B transpose U transpose B transpose J omega identity minus A minus Hermitian minus J omega identity minus A Hermitian P j omega identity minus a inverse b u equals minus u transpose b transpose j omega identity minus a inverse bu. Okay, let's call it 3, and let's focus on this term now. This is going to be the fourth one, and u transpose b transpose j omega identity minus a minus Hermitian pb plus c transpose d, okay, r inverse b transpose p plus d transpose c, okay, j omega identity minus a inverse b, this is b, times u equals, well, you might wanna change this r minus half and r times r minus half, okay, and if you do that, you are going to see that this part and this part is like x transpose x, and we can write this, right? That kind of notation we can use, and r minus half b transpose p plus d transpose c, okay, j omega identity minus a inverse bu, okay, and this is the fourth one, okay, this one's this, okay, sorry. Well, this was the my first page, and I have one other page, the last one, for the sufficiency, by the way, not for the necessity. Necessity is going to be another type of challenge for us. I mean, we might make it another video, like in 2 parts or something. And this proof I searched everywhere, but I didn't get to see a comprehensive and compact demonstration of the proof. So, okay, well, at this moment we can just write C. I wanna adapt a notation that will kind of make things easier, but I'm afraid that may confuse some people. Okay, this is, I mean, I have to, right? I'm going to do 2 part, I guess. Let's use this notation phi, or rather I'm going to be more careful with my space. Phi equals, right, j omega minus a inverse, okay, this is like notation, right, definition rather, and C phi B U 2 okay, less than equal U transpose B transpose phi Hermitian PB. By the way, I might use transpose instead of Hermitian, so watch out for that. U transpose B transpose P phi BU minus, right? Okay, R minus square root and B transpose P plus D transpose C. Okay, phi B U. Okay, well, it says this, since determinant of J omega identity minus A is not equals 0 because A is like symmetric, right, for omega in R, and also A doesn't have eigenvalue on JR, right, imaginary axis, and then the equality only holds when equality only holds when BU equals 0. Alright, and not that, or as if that was not enough, Duan and U want us to add these terms, U transpose, right, U transpose D transpose D plus D transpose C phi B plus B transpose phi H C transpose du. We are going to add this term to the both sides of this inequality, right? And this is also equals to U transpose gamma square identity minus R plus D transpose C phi B plus B transpose phi Hermitian C transpose D U. Okay, I'll just change this term. Instead of D transpose D, I just written this. Okay, so not a big deal. And I'm looking at this. Let's consider this in two parts, okay? And let's focus on this part. We are going to add this to this and then record that. Alright, looking at this. First of all, I'm going to write this in another form. Okay. U transpose D transpose C phi B plus D transpose D plus B transpose B, no, B transpose phi transpose C transpose C phi B plus B transpose phi transpose C transpose D U. Okay, all right. Here, this term here, this term is here, this term is here, and this term is here. Okay, C F B U. Okay, C F B. Okay, so everything is okay. I feel like I made a mistake, but okay. I should stop pressing the wrong buttons. Okay, and yes, this is, and if we very carefully look at this, we are going to see, and this is like really hard to see. We are going to get this. And before you say, how could you get this? Let me just, okay, let's remember what G is. C SI minus inverse B plus D, right? Okay. And we were going to use this notation. Okay. So C phi B plus D, right? Times U, right? U transpose and C phi B plus D transpose, right? This is this, okay, this expression, okay, and let's expand this a little bit. Before expanding, let's not focus on the U and just focus on the inner terms. B transpose phi transpose C transpose, right, plus D, and C phi B plus D, and first this term B transpose phi transpose C transpose C phi B, okay, and then second plus B transpose phi transpose C transpose D plus this term D C, come on, not D transpose, this is D transpose, okay, D transpose C phi B plus D transpose D. Okay, let's check this if that is correct, if the terms match very. Okay, D transpose, okay, that's correct. And DC FB, yes. Wait a minute, I made a mistake. Yes, DCFB. BFC and CFB. right? Yes, this match. And also BFCD. Okay, so the calculations checks out, and I'm just going to delete that because I need a space, right? Come on, delete. Okay. All right. So we just added this, and now this term is GU. So and now we're going to focus on this part, right? All right. All right. Well, this is not going to be easy. Let me tell this. And you know what? Before doing that, let me write the right hand side of this part. In a expanded manner. So I'm only going to focus on the right hand side of this inequality, right? U transpose P, no, E transpose phi Hermitian, or I'm gonna just say phi transpose, okay? P B U plus U transpose U transpose plus U transpose times B transpose P phi B U, okay, minus U transpose, it's going to be long, B transpose phi transpose PB plus C transpose D R inverse and B transpose P plus D transpose C and phi B U. Okay, I just written right hand side, and now I'm going to add this term, right? But before doing that, I wanna adapt a notation. I'm gonna call this X, okay, and I'm gonna call this X transpose. Otherwise, it's all gonna be very hard for me to write them. Well, so I'm going to add this term to this term, okay, and see what we get. Okay, and since there are u's here, and here, what I mean is every term is U transpose something times U. I'm only going to write this like term 1, term 2, right? Dot. I'm only focus on this part, right? This is my one of the first videos, so be gentle in the comment section. Yes, one by one. Okay, one by one. B transpose phi transpose P B plus B transpose P phi B minus B transpose phi transpose X transpose R inverse X phi B, and now we are going to add this, okay, gamma square identity minus R plus D transpose C phi B plus B transpose phi transpose C transpose D. Okay, and these are again the added terms. These are these terms. Okay, I'm going to B transpose phi transpose notice B transpose phi transpose something and B transpose phi transpose something, right? We are going to group them together. PB plus C transpose D, and here C transpose D, right? And so we just did this term and this term plus phi B and where is it, phi B, okay, B transpose P plus D transpose C phi B, okay, we just did this term and this term, we group them together, minus where I'm just going to write this as is B transpose phi transpose X transpose R inverse X phi B, alright, plus this term gamma square identity minus R and this term, okay. Alright, one by one, right? And notice this is X transpose, this is X transpose because here, alright? And notice this is X, alright? I'm just going to write this again, B transpose phi transpose X transpose, okay. I'm gonna leave a little space here that I'm going to explain the reason why I did that. This is X phi B, okay. I just written two first terms minus B transpose phi transpose, right, X transpose R inverse X phi B plus gamma square identity minus R, okay. At this point I want to write I mean, we can just write identity here, right? Something times identity equals that something, right? And R inverse times R equals identity. Alright, so I can just write R inverse times R, and this will be a valid operation, considering that we are being careful with the dimensions, right? R inverse R and R inverse R, right? And okay, we're getting closer, by the way. We're getting closer. So let me just write this as minus x phi b transpose, okay? R inverse x phi b, alright? And then let's write this term as plus x phi b transpose, right? R inverse R, okay? And this term I'm going to write now. This is not, wait a sec, just let me get rid of, not R inverse R, rather R transpose R inverse, because R equals R transpose, so R inverse R is identity, and right, this is identity because this is R, right? This is all going to make sense at the end, or does it? You're going to find out. So R transpose R inverse, I'm just writing this term, right? X phi b, okay, and minus, right? I'm going to write this as, I can write R, right? But I also can write R transpose R inverse, which is identity, times R, right? And you're like, there has to be a reason for that. Yes, there is, in fact. R transpose R inverse R gamma square identity, okay. This term is this, and this term is this, okay. Alright, by the way, I'm literally doing step by step, so that's why it takes a lot of time, and that's why people don't do that on public. Well, 1, 2, 3, and 4, okay. These 4, 1, 2, 3, 4, yeah, these 4 terms, actually, I mean, I know you are really able to see that it is really easy, it is really it is really easy or obvious to see that, I bet. x phi b plus r transpose r minus half r minus half, right, minus x phi b plus r. Okay, that is this term, this 4 terms equals this term, right? And now I'm going to write this plus square. And before that, I'd like to talk about this. Okay, well, if you expand this term, like there's going to be like 4 terms, right? You are going to get these 4 terms, and for that I'm going to be a really cool person, and I'm also going to show that how you may do that, right? I'm going to call this minus x phi b a, right, minus a plus r transpose. I hope I can do that. By the way, I'm supervising right now, and I'm not sure about this. Okay, I mean, there has to be a reason for this. R inverse, right? Okay, just minus a transpose minus r transpose r inverse a plus r, and r inverse a plus r inverse r. Okay, minus a transpose minus r transpose minus a transpose r inverse a, then minus a transpose r inverse r transpose, no, not transpose, just r. Okay, and now this term minus r transpose r inverse a minus r transpose r inverse r. Okay, let's check the terms one by one. Okay, this is the first term. Remember, we just call a minus x phi b, right? And let me check this. This is the second term. I hope we are not missing a minus. Right. Of course. Minus, and here again minus, so it's plus sign is okay. And here are minus. Okay, this is this term. Okay, and this term is this term. Alright, everything checks out, so we are really happy with this result. Okay, so we can write minus omega transpose r minus half r minus half omega and plus gamma square identity. Okay, and here notice this term is like a transpose times a, and this is like this term, right? So minus r minus half omega w u 2 plus gamma square identity. Okay, and you're like, well, did this u come from, right? And remember, we were just omitting u transpose u terms, right? So this was actually u w transpose r minus half w u, right? So it is like r minus half w u. This is it. Okay, and also now that we remember that, now that we at this point we are going to just restore u transpose something u terms, u transpose gamma square identity u, right? And we can write gamma square u transpose identity u and gamma square u transpose u, and or rather gamma square, right? Okay, this is perfect. Gamma square u. Okay, yes. Gamma square u. Alright. What was the other term? Let's remember that term. Yeah, it is not that far away actually. This was the term. Let me just write this. GU square. This was like this, right? Yeah. Here. Okay. Minus alright, since we have this, and since this is a positive quantity, and this is like we subtract something from this term, and reach this, and we can just write, right? If that inequality holds, that inequality holds as well, and this is like the magic thing, because GU right, this is square root of each term. No, okay, and this is the definition of H infinity. Ta-da! And this was the sufficiency part of the proof. So let me check my notes. To see how much time I need for, where is it, for the nesty. Let's see how many pages I have for this. Well, it is like 2 pages, but we can do that,